Continuing NCC for AT2 4002.
Building in the event of a fire. So, for instance, let's just take this roof. And our compartments in accordance to the NCC would be much bigger than this. But if we took this room and we said that we want this end to be one compartment and beyond the shelves there to be another compartment in the event of a fire, so that if in the large buildings, say like a hospital or something, we've got patients on beds and they're not going to be able to carry everyone down the stairs in the event of a fire. They want to be able to move people from one compartment to the other and still keep them safe. And so, you know, we talked about the FRL levels of being maybe 1 hour. They can be up to 2 and 3 hours. So you would say that we may make this wall, and let's pretend that the shelves are a wall. So we could make this wall construction to be 2 hour fire rated and this wall to be. And we could put some fire doors here. The fire doors, we may not want them closed all of the time in the building. Sometimes you'll be in buildings that have fire compartments and you won't even realise the compartments are there because the fire doors will be held open, and they're normally held open by a magnet control. And in the event of a fire, when the fire alarm goes off, it releases the magnet, the doors close, and that becomes a fire compartment. Now, you can still use the doors for escape in that scenario, but they will be self-closing and they'll close up. And so you could move everyone from that side of the building into this side of the building and then be closed for 3 hours. Or whatever rating your compartmentalisation has. So just a little bit about compartmentalisation. We've identified that in this apartment building, it's not big enough to warrant that, no. But it's especially, you'll find that sort of compartmentalisation for fire in big buildings, especially hospitals, aged care facilities where they know it's going to take a long time to do an evacuation. So what they're doing is creating safe compartments. And so it works both ways. The fire could be on this side and we'll move everyone over there, and the fire could be on that side and we'll move everyone over here. So the best example I know in Darwin of a compartmentalised building is RDH, Royal Darwin Hospital, and it's absolutely built like that. It has a stairwell in the middle, and it has all the elevators in the middle, but on either side of that central circulation shaft is a separate compartment on every floor. So in the event of a fire at our hospital, it's 8, 9 stories high. They're not going to try and lift all these people, sick people who can't walk and can't use the stairs. They can't use the elevators in the event of a fire. So they're not going to try and carry them all down the stairs in one time. That would be just chaos. So what they will do is they'll move all the patients on level 8 from level 8A over to level 8B if the fire happens to be in that compartment. And they'll do the same on all the floors. So each floor is 2 compartments, and they'll move people from one side to the other in the event of a fire.
What she said. Thank you. So I've just been scrolling down and I found in part E2 a reference to buildings not more than 25 metres in effective height for class 2 and 3 buildings. So our class 2 is us. And there's just, why am I walking away? So there's a little note here that says a class 2 building or part of blah, blah, blah must be provided with an automatic smoke detection and alarm system complying with the specification. So we're going to link to the specification and have a look and see what that says, and hopefully I can make some sense of it. All right. So a required automatic smoke detection and alarm system must comply with the following. For class 2, a smoker list... Oh, here we go. Bear with me. Class 2 in buildings and class 4 in buildings subject to this, which is what? Class 3 building, no. Previous view. Nope, that's annoying. Damn. Oh, here we go. So a class 2 building subject to a class 2 and 3 building and 4 part must be provided with a smoke alarm system complying with clause 3. Okay, so next line down. Here's clause 3. Smoke alarm system. Thank you, here we go. So a smoke alarm system must be consistent with smoke alarms complying with AS 3786 and be powered by the consumer mains source. So I've made a note here on the checklist. You can see it there. It says smoke detection to be installed as per 3780. And I wrote 8. It's actually a typo. Make it a 6. To be hardwired to the consumer mains and have battery backup. So
we spoke about this yesterday.
Oh, you did?
We spoke about this in terms of the residential building, because that's come into effect for the residential building now. If you're building new, your smoke alarm has to be connected to the mains power, has to have battery backup. In other words, your mains power will be charging the battery, and in the event of a power failure, the battery backup will keep your alarm system going for probably 24, 48 hours, whatever the battery capacity is. But that's also the exact same for the apartment buildings. Same as we have in our Class 1 residential buildings, we have to have in each of the apartment buildings here.
Yeah. I think when the fire inspector comes to commission the building, they cut the power quite a far way back, like back to a different transmitter further up the road, to really check and make sure that all the exit signs and smoke alarms and everything still work. It's not even just localised power that they cut. They go back an extra, I don't know what difference it makes to them, but apparently it does. So yeah, they really test those sorts of things. Excellent. I would perhaps note on the drawings where the smoke alarms can go residentially. So let's have a look at our floor plan.
So that should probably be noted on the sheets that show each apartment individually.
That's a good idea. Because they're the same on each floor, that's called typical. So you'll just get one zoomed in view of each unit, and this one is a mirror version of the one below it. Remember we said this one's just the same but flipped over. So wherever you choose to put the smoke detector here, it'll be the same in the opposing typical. What have we got? We've got a balcony. Here's the kitchen, our source of fire. Here's our exit. Here's our bedrooms in this unit. Here's our bedrooms here. That's where people will be sleeping if there's a fire in the evening. And this is perhaps where the fault might come from. The most common location of house fires is from the kitchen. So this is the passageway exit to the front door. So we really want to know if there's any smoke in the building before it gets too far down this corridor and affects the people in the bedrooms. So I'd perhaps suggest that somewhere here might be a good place for the smoke detector. What do you think? Perhaps about there? Because then it's between the kitchen and the bedrooms, and it's before the exit. So that if the smoke starts to come out, the alarm goes off here, and the people in the bedrooms have got time to escape. How's that sound? So use that same icon, the circle with the half colouring in, and SD as the abbreviation, and make a little legend on your drawing that says SD smoke detector. Yeah, go jump into it. Do you want me to push it over? Let's have a little play. This is a nifty little setup, hey? This one. What do you say? Moving what where?
Moving this over here eventually. I'm moving that desk just over to there on that side.
Yeah. Oh, we can if you like. That was Chart's idea of a reception desk.
Yeah, right.
He wants an actual reception desk. But that'll never happen. It's not really necessary at all. Yeah, I was going to say it's just not even. That's why that's there, is all that is. So that could go entirely. We don't even need to have it.
Can we sit around here somewhere?
Yes, I think so. Beautiful. SD. And I would probably also write on my drawings ionisation type alarm. I better write that out because it's unusual spelling. There's my other big... oh yeah, why not? So we've got our little figure, SD, smoke alarm. Usually to the right. I had a feeling you might say that considering you asked. And then a little note under your legend, you can say ionisation type alarm, more suitable near bathrooms. photoelectric alarm suitable, bless you, near cooking appliances. So I would put required. Just excuse my awful writing. It's the same phrases that are on your checklist, so I didn't worry too much that you would have to be able to read it because you've got it right there in front of you. I would put on our checklist required next to the point in the checklist that says smoke detections to be installed, and then I would put a little note saying location noted on drawings. So the checklist and the drawings are working together, and you're saying, yes, you have to have them, see the drawings for where. Now we've got another set of plans, a different unit configuration.
Sorry, I have a question.
Yeah.
I've got a different plan.
On the other side. That's okay. Yeah, no, that's the same.
Because I was going to say that then this one is here as well, right? Because it's in front of the bedroom.
Ah, I didn't notice that door there. That's quite nifty. Good on you. Let's have a quick look. I'll go back to where that was. Whoops, oops, oops. Yeah, that's quite interesting. See, this bedroom's got a doorway here. I didn't connect that. I didn't read it properly. I just put everybody coming out this way, but it's here. So our option is, I suppose, to put this up a little higher, and then it will still take care of all of them. I probably would be surprised if somebody would go to the trouble of putting two, one just here and one just there. I think probably we'd just move this one up a little bit. Don't be too concerned. I think we're pretty close to the mark, and it's just a preliminary design idea, but that's excellent observation. Thank you for that. So just bring it up a little higher, and it would take care of both. We don't want it too close to the kitchen because we don't want to set the smoke alarm off inadvertently. If you set an alarm off a lot by mistake, you create a strange behaviour, a complacency. People always assume that it's a false alarm. So if you're asleep and the alarm goes off, you just think to yourself, oh, that damn alarm is just going off again, and you may not respond quickly when in fact it's a true alarm. So you don't want to get it too close to the kitchen, and I may have drawn it slightly too close, in fact. But you don't want to set it off too often just by burning the toast or steaming the pasta or doing anything silly in the kitchen. So we do have to be careful that we don't create the wrong behaviour. You can actually get quite unusual smoke detection alarms that will also emit an odour to wake people who are deaf. So it puts out like capsicum spray or wasabi spray, like horseradish and things. It wakes you up. It's not pleasant, but it's effective. Yeah, it actually emits like a spray. Probably has to be a lot closer to the bedroom, but it can be done. Yeah, weird, huh? Good tip, thank you. And so on this one, I'll watch a bit more closely. Be a bit more careful this time. So we've got kitchen right up the front or down the back, depending on which way you look at it. And then we've got two bedrooms right near the entry, which is kind of handy. So if we put the smoke detector right before the passageway, everybody will be fully alarmed. How does that sound?
And do we have to add legend to this plan as well?
I prefer it is on the page.
I usually put a legend on every page.
Do you?
Yep. Yeah, try not to send references back and forth too much.
Okay.
Yeah, only reference what's on the page. Don't feel like you have to do a legend for every abbreviation that's in the entire set on every page. You only reference what's on that page, but try and keep people on the same drawing as best you can. Yeah.
E3.3.
Ah, the lifts on warning. Cool. It's a daisy. Oh. Does it work?
2.2, so we should be on 2.3.
I think we're done with E2.
Yeah.
And just click on E3, lift installations.
Oh,
yeah. I think we're done with smoke. Nice. E3.3. Yeah. I won't go there today either. Why not? That's so weird. If you go right click, does it let you? Go to bookmark? Does it? It was doing it the other day. You just clicked and it went there. Nuisance. Alright, cool. All good? Moving right along. E3, lift installations. Now, we've got section 2 done. Part E sections is about lifts. It's mostly just about E3.3, warnings against using lifts in a fire. So that's relevant to us. It's not on the checklist as explicitly as I'd like. I've got a little note here, and you'll need to add it to your checklist. Where it says E.3 lift installations, that's all I've written for that whole clause, which is really a little less specific than it should be. You see that, Andy? You're okay? Can I, Andy? You're okay? You've got it? Yep. E3. Is this the class 2 checklist? You need the class 2 checklist. No, that's class 1 from the other day. I think so. No, that's class 1 and 10. Is that class 2? Just double check. You don't want to be using the wrong one. Have you got a stapler? You can put it all in order. Don't rearrange things too much. Yeah, no, that looks good. It's just you're in a funny order. Let's have a look. See if you can find the first page. It'll have class 2 building permit checklist on the front.
No.
Just put that one aside so it doesn't get mistaken for the wrong thing. Yes. So just look for the first page, class 2 building permit checklist. Would you like me to rearrange things for you? Just at the top, the heading here. That's what we're looking for. There it is. That's the very first page. Okay. Now the second page starts with flood site. Should be on the back. All right. So put that face down. Face down. That's it. And then the next one will be D1.2. Okay. Face down. The next one is construction and wet area. That's it. Face down. Good, good, good. Then drainage. Leave it there. There's more.
No, I need to,
Wait. There's more. Yep.
More?
Drainage. Face down. Then accordance with the NCC. Excellent. Face down. Then 2 rises plus going. That's it. Face down. Then light and ventilation. Yep. Then high wind provisions. All right, now staple that. Yes. So you want to go to E3 lift installations and you want to add a note, E3.3 warning. Yep.
No, I didn't.
Drawing.
It's funny because, when I'm working with when I'm actually working on that job, it repeats in your head if you do it.
On the floor plan where you can see the space created for the lift, you might want to put this note. So clause E3.3, warning against use of lifts in a fire. So So there needs to be a warning sign displayed where it can be readily seen near every call button for a passenger lift or group of lifts throughout a building, except a small lift such as a dumbwaiter or the like that is for transport of goods only. So they're very small elevators that you can't fit a human inside. You don't have to have a warning sign for those. And then there's quite a bit of detail with regards to the size, the contrast in colour of the letters on the sign, and there's a whole figure that you need to follow. So the manufacturer of the lift will provide the sign and make sure that it's connected, and it's just a part of the NCC to make sure it gets done. So it's this do not use lift if there is a fire notice.
So the compliance requirement for this part of the NCC is to provide a sign everywhere there's a lift that says do not use lift if there is a fire.
It shows the size of the font. And it normally has to be contrasting colours like red on white so that colourblind people can still read it. And it's usually done in Braille as well for blind people to be able to read the sign as well.
Not a whole lot of point of putting up warning signs around the building if you're going to camouflage them.
Yeah.
They need to be bright, they need to be readable, they need to be obvious to the users of the building.
Battery's flat. This one's okay. It's weird. I'm going to plug it in. Yeah, no, I did too. It was flashing green, and then it was flashing red and green, and now it's off. Beg your pardon, Joanne?
The clause number for that.
E3.3. Yep, section E, clause 3.3. So you would put required, and then that would probably be it. You can't really show it on the drawings because we don't have any internal elevations because they're going to be on the inside, just next to the button that you press to bring the lift. There'll be a sign there saying, don't use it in a fire. I'm sure everybody's seen this kind of signage everywhere they go for every lift. So it's quite familiar. I don't think we can really audit on the plans, but you perhaps just, I'll go back to that writing, that text, and you'll be able to see it, and you could perhaps write that phrase. A warning sign must be displayed where it can be readily seen near every call button for a passenger lift, as per figure E3.3, because the figure gives you the diagram. And that would be a good way to reference the NCC on your drawings.
So what are we saying, noted in drawings or?
You can't really note it in the drawings because we can't show an image of the face of the lift. There's no internal elevation, but you can put a little clause list on the drawings. That's a good thing.
On the checklist?
If you can fit it on the checklist, you can put it on the checklist, but it's probably just as easy to put it on the drawings. There's a bit more space.
Okay. So we like put that
Either one is fine. It'll be required.
required, that's what
Yes,
I'm saying.
required is what we want. So it's not compliant because we can't see it. It is required in the drawings when we do draw them up.
So where do you think, Ed, you know, when we eventually get to the point of doing a working documentation for this building, where do you think that information might be? So we need to convey to the builder that he has to provide a sign that says, by the lift, that says do not use them in case of fire. So how do we tell the builder that? So remember, you're not going to be talking to this builder, you're going to be handing him a set of documents. That's the contract, the set of documents. How would it be on the drawing?
On notes, on the bottom.
So usually either that, we can write general notes on a drawing. So we could have, in the general notes, we could have one of the points would be, please provide, where there is a lift, please provide an additional sign in accordance with, and we quote the clause, and we quote the, was it an Australian standard? No, it wasn't.
No, that was for the smoke detectors.
The clause.
Yeah.
So we would quote the number of the clause, and so that we know we're telling the builder then that he needs to refer to the NCC to know exactly how big the lettering has to be and all of the rest of it. So in addition to your drawing set, sometimes you might have a document called the specification that goes with the drawing set. So often on a bigger building, these type of notes would be in the specification. You might have a whole section on signage in the specification. It'll be text. The specification is pretty much like a report, or it's an instructional document that's text. And in there somewhere you might write, and if you were writing a specification, you might have the note in the specification that is directly from the NCC, and you've written it out exactly what the builder has to do, how big the letters are, what the text has to be, how big the sign has to be, and it goes in there under signage in the specification. So 2 options. One, it goes in the drawings or goes in the specification.
So section 3.4 is about emergency lifts, which we don't have, but it's required if we've got an effective height of more than 25 metres. So we can skip over that for now, but just be aware that there is a clause about emergency lifts. Access and egress to lift well landings, passenger lifts. So this is about an accessible building. Not too much about what we are dealing with, but we'll have a quick look at it nonetheless. All different types of lifts here on the left and the limitations of their use. Electrical passenger lifts, electro-hydraulic passenger lifts, stairway platforms lifts. Is that those ones that are on like a railing that go up the stairs? Mm-hmm. Yeah, right. Incline lift, a low-rise platform lift and a low-rise, low-speed constant pressure lift. My goodness, all sorts of stuff. And a small-size, low-speed automatic lift. And the distances that they can go, those types. That's quite specific about products that would be manufactured by other companies that would have a lot of specifications about that sort of stuff too. So it's surprising to see that level of specificity about different products.
Mm-hmm. I think it's more to, what they've said here is more to do with, you know, so if you have a building where you need to provide disabled accessibility, they don't want they want you to put in like a lift as we know a lift. That, you know, we walk into most buildings and we see it. There are all other options for that. There are just platforms that go up and down. You're not enclosed, you're just going up and down the platform, which is often described as a goods lift. So there, you know, it could be used for that. There's often service lifts in hotels especially that are not used by the patrons of the hotel. They're only used by staff and really for moving goods around more than people. So there are many, many different types of lifts, and so I think this table is really more talking about what type of lift you could use where. So you can't expect someone in a wheelchair to go around the back of the building and use the goods lift to enter the building. That's not acceptable. Yeah.
So, or go up 86 flights with one of those stair lifts that takes forever. We want something faster. Yeah, that's probably fair. And then there's some information about the application of features, so handrails and floor dimensions. Again, they're probably governed more from the requirement from the lift manufacturer. So you've probably all seen the signs when you get in a lift, maximum capacity 6 persons or 4,500 kilograms and things like that. So there's probably quite a bit taken care of by the manufacturers themselves.
And, you know, when you are looking at passenger lifts, if you ever do have to specify one, really you should be consulting with a mechanical engineer on the specifications for the lift, because there's lots of other considerations. Usually lifts either need additional room for the mechanism either at the top of the building or sometimes in the basement of the building. They can go either way, top or bottom. Normally they go top, which means that your building will protrude. We've all looked at movies where you've got, you know, they're all running around on the roof, and often there's a little pop-up on the roof, which is the door, the access to the roof. There often is pop-ups for the lift plant up on the roof, which may make a difference to the height, the overall height of your building. So that's really what you've got to look out for with lift design. But you should be talking to your mechanical engineer, and you should also be looking for a brief from your client on the capacity of the lift that they want. So you can get really, really small lifts, only a couple of persons can fit in there. But please, in an apartment building, a passenger lift, not only is a passenger lift, it's also a furniture lift for the people who are moving in and out of the apartments all the time. So if you restrict that building to only having an elevator that is, you know, 2 persons, you're really not going to get the sofa in there as well, or the fridge. So think
or
about
a person in a stretcher being taken away by paramedics.
Exactly.
Yeah.
So the ones that are fortunate to have a lift really high, like 4, maybe sometimes even 12 floors high, and they've got this like 1 square meter.
Yes.
So my sister lives one that's got like maybe 5 or 6 floors, and crammed with a bed in there.
Oh.
So we sort of kind of squeezed it in. I kind of like changed it a little bit, and then I could barely fit in there.
Wow.
So
That's rough.
There's no chance we'll be able to,
No furniture.
yeah, no, or a patient
Yeah, no. Yeah, that's a bit rough.
stand up.
Oh dear. Yeah, that's not good. So E3.7 is about fire service controls. So it's when the lift serves stories that are greater in height than 12 metres. So we've got 3 stories for our lift, but that's probably only about 9 or 10 metres, so we probably don't quite hit the limit that we'd need for this. But if that was taller, you just need a fire service recall control switch. So that's about being able to bring the lift back down to the ground floor in the event of a fire. So it would be up to the fire service engineers to decide whether that was necessary or not.
So the patrons of a building are not allowed to use the lift in the event of a fire, but the fireys do.
Yeah,
Yeah.
but that also is because if someone's stuck in the lift at the time of the fire, they can sort of
They can bring them down.
Yeah, if it happens to be that halfway through the trip they get stuck. All right, so we don't have an aged care building, so 3.8 is not for us. And there's information about labels for fire service recall control switches. Lift car. And lift installations. So there's quite a bit of information about lifts. E4, here we go. So visibility in an emergency, exit signs and warning systems, part E4. This is the bit that I've been trying to get to. Emergency lighting requirements. So an emergency lighting system must be installed in every fire-isolated stairway, fire-isolated passageway or fire-isolated ramp. So that's like the corridors and stairs that we were talking about where it's completely closed in, there's no openings, it's all solid concrete, there's a fire door at the top and at every floor all the way down, and you'd have to have emergency lighting in there, obviously, to be able to find your way. And that lighting needs to stay illuminated when the building power is cut, so it's a mains back up further back than the main building, which is probably why they test it so far back. Let's see what we can find that applies to us. In every story of a class 5, no, here we go. In every passageway, corridor, hallway or the like, having a length of more than 6 metres from the entrance doorway of any sole occupancy unit in a class 2 building, part to the nearest doorway opening directly to a fire-isolated stairway or an external stairway serving instead. That's us, isn't it? So we've got a non-fire-isolated stairway because we didn't have to have fire-isolated because it's not tall enough. But we've got an external stairway serving instead of a fire-isolated stairway. So we have to have in every passageway, what do we have to have? Let's move forward. We have to have an emergency lighting system.
So if your corridor is greater than 6 metres long, from
Which
the
it is.
door of the apartment to where that person might enter the fire-isolated stairs, then you
Yeah.
have to have an additional emergency light.
And it says corridor, not path of travel. So we've already checked the path of travel, and the path of travel is just within the 6 metres from the nearest point of the door opening to the landing at the top of the stairs. But there would still need to be emergency lighting because the passageway is longer than, down the other end is further away than 6 metres. So you'll probably have a free hanging sign like that just above the top of the stairs. So then that illuminates, but it also draws you towards it so that you know that's where you need to go down if it's all dark and smoky. Just looking to see E2.4. E4.5. Here we go, exit signs. So an exit sign must be clearly visible to persons approaching the exit and must be installed on, above or adjacent to each door providing direct egress from a story or door from an enclosed stairway or horizontal exit. Door serving as or forming part of a required exit. So we don't have any doors at the top of our stairs, but it's a horizontal exit. So we want to make sure that we've got an exit sign just above that, which is exactly what we were just saying. So here on the checklist, you'll see exit signs to be installed as per NCC E2.4 and AS 2293.1. I would also and I've made a note here, it's actually E4.5, exit sign required. And the note just below it references the emergency lighting that I've was talking about before, so you could add that clause as well. So that was E 4.2. E4.5, exit sign required. E4.2, emergency lighting required. Now you'll often get them combined together, the exit signs and the emergency lighting. They're the same product. So you can see there's lots of light coming from that exit sign. So it kind of does a double duty. Sandra, I'm just trying to do a quick search within this PDF. So I did Control F and this toolbar popped up on the right. Do you know how that works? Because I've got this note here, E5, maintenance of safety installations, but there's no E5. So it's about maintaining all the equipment. That's all right, I'll just have a quick scan through, I might be able to just find it.
Section J, about maintenance and access, but
Odd. That will have to stay a mystery just for now, that's all right. No bother.
where the checklists are, I won't even print a copy of this.
In the same resources with the student for everything. In the assessments resources, I think. Yeah. So on my little checklist here, the next item says E5, maintenance of safety installations. Quite sure what was happening when I wrote that, whether it was so long ago that the NCC has changed or what, but there's no E5 anymore. So we'll just leave that as a mystery. Not quite sure what that is about, but obviously it's important to maintain equipment and safety installations. So we've just gone to all this trouble to include emergency lighting and exit signs and fire hydrants and not sprinklers, but equipment. And you have to make sure they're going to work in the event of a fire. So, and you probably see quite often personnel coming by to test equipment or check equipment, make sure it's got the right pressure or still connected and working. We don't often turn the sprinklers on, but there's a way that I'm sure you can test the pressure to make sure that it's operational. It's not very nice water that comes out of the pipes. And from what I understand, if you do actually have to use the sprinklers, the water that comes out of the pipes that's been sitting there for a while is probably going to be pretty disgusting. So if they go off in an accident, it can be pretty awful because it's not only is it water, but it's dirty water. So it ruins everything. So we don't want to test it as such. We don't want to try using it, but we want to make sure it does work. So there's some Australian standards listed there about the requirements to maintain that sort of safety equipment. And I think it used to be in the NCC, but it's not there now. There's quite a bit of information here in specification E4.8. so in conjunction with clause 4.8, there's a spec with regards to the way the illumination and the exit signs should work. If there's a person, they need to be going in the direction that the sign is leading you and things like that. So there's a bit of an art to installing good exit signs.
Yeah, so sometimes the electrician will only have, an exit sign. For instance, this man is telling us to run this way, and we know it's the correct way to go. But, if the electrician has the wrong sign on the day and he puts the man facing the wrong direction, that's again, non-compliance with the NCC. He's got to be running in the direction that you're advising people to run in. That's really important. Yeah.
Yeah. And we're saying man, person, whatever. Yep.
Yeah.
Go where they go.
Yeah.
Used to be just arrows, I think, but now it's people. Mm.
But for you guys, it's really enough to know that you need to have a note on your documentation, whether it be on the drawings or the specification, to say that these things need to be in compliance with these particular clauses of the NCC. You don't really have to go into any more detail than that. You need to be aware of it yourself. So when you're doing site inspections, if there are no emergency lights, that you do say to someone, there are no emergency lights, where are they? But and you also need to have them obviously on your documentation. But you don't need to go into the big detail of them. You don't need to tell on the drawing, oh, the man needs to be facing in this direction. That's too much detail. As long as you're saying in your note, in accordance with clause or Australian standard, like we've been discussing, and writing down the names of the clauses, then that's enough information on your drawing.
It's a lot, isn't it? All right, section F, health and amenity. So quite familiar to you from yesterday with our Class 1 and 10 buildings. We're in a unique building where a sole occupancy unit behaves very much like a Class 1 building might. We don't call it a Class 1 building because it doesn't have any connection to the ground, but it's the same kind of activity inside. So a lot of the waterproofing in the wet areas is the same. Obviously the smoke detection we've just done is the same. And the room heights will be the same. So there's quite a bit of familiarity there for you already for sole occupancy units. Now this clause doesn't just take care of sole occupancy units, it covers all different commercial classes. So there'll be a whole bunch of other information in there we'll go to for the next assessment. But for this one, this will be reasonably painless because it's familiar. So damp proofing and weatherproofing. Now you'll probably find one of the first things I'll say is to make sure the outside is weatherproofed. Let's have a bit of a look here. This is all the verification methods. I'm just breezing on by. Here we go, part F1. Stormwater drainage. Okay, so it just says stormwater drainage has to comply with the plumbing code, 3500. That's a good idea. Let's just make a note of that. Yep. I don't think I've got that on the checklist, so I would definitely add that to my checklist. So F1.1, stormwater drainage. I'm going to have to make a note myself. Yeah, oh, it's okay. I'm just adding.
So a note about stormwater drainage would usually appear on a site plan. Yeah. Or again, a lot of these notes could be in a specification document if you were developing it. Or you could have a general note page at the end of your drawing set. But for the purposes of what we're doing for the assessment, as long as it's on your drawing set, and I would say on the site plan, that's fine.
I've been,
Brilliant.
this is, yeah. So, AS 3500 is the plumbing code. It's the whole plumbing code. So it's quite a broad phrase to put that, but that will cover you. The site plan is just an A4 piece of paper, that sketch. What? Sorry, it's not A4 because this is the bigger project. Apologies. Yeah, that will work. And there's another one as well. That's the one, yeah. Slightly larger. Yeah.
It looks like a roof plan because we often show a building with just a roof plan on the site.
But I would be happy with just seeing that as another row on your checklist, and then you could put required as well as the note. Yep.
Yeah, maybe it's not. I'll have a look at it.
I'm not sure. I'm not sure off the top of my head now. I get that confused. It should be 4002.
Yeah.
It should be. Well done, everybody.
If you haven't already done so, now would be a really good time to write your name on your checklist, because obviously everybody's got the same checklist. And just write your name and your student number on the top.
Just in case.
Just in case.
1.1. F1.1. Sorry, I've got it hidden. F1.1, stormwater drainage. So that's about making sure that any rainwater or stormwater is managed properly. It's not okay to let the stormwater just run wherever it runs. When you build a roof, it collects rainwater and you have to do something with it. So gutters, downpipes and then into the stormwater system, or shedding to the road with the land or being absorbed by the land. Might also mean you have to have some drainage around common areas and things where you've got paving or gardens, just to make sure things don't get flooded. We had a lot of rain up here, so you have to think about that stuff. Alright, so F1.2 and 1.3 have gone, but F1.4 is external above ground membranes. I'm having a hard time picturing what that looks like. Do you have any idea?
Yeah, so we use membranes in a lot of places in our building. So the most common one I suppose we see is underneath the floor slab, so that's not above ground. That's soil, so it's underneath the floor slab, and that's to prevent rising damp and moisture coming up from the ground and penetrating through the concrete slab. Concrete is not impervious. A lot of people tend to think it is. It isn't, and water will travel through the concrete if you don't use damp-proof membranes. The other areas of the building we may use the membrane is in our walls. So if you're using lightweight construction and you've got steel construction, we might use something, and we normally think of it as isolation, but that can also be a waterproof membrane. So isolation is a product that looks a little bit like, I don't have any of the lighter foil, maybe I do. Have a shape of
No.
This is more, this is called isolation. It's got a little bit of an air bubble in it. It's a reflective foil, but it is also a waterproofing membrane because it is impermeable. Now you can get isolation that is breathable. If it is breathable and air and moisture can go through it, then it is not a waterproof membrane. But if it is non-breathable, then it is a waterproof membrane. So the other area we use it in is in the roof. We often again use this product like this underneath our roof sheeting. Sarking, when it's referred to as sarking, it's referring to a waterproof membrane that is the sarking. When it's referred to as isolation, it means that it's got some insulation properties to it. And when it's referred to as reflective foil, it means it reflects the rays of sunlight. So this one membrane tends to do quite a few different jobs, but it certainly can be a waterproof membrane that is above ground.
Okay. So they've got an Australian standard to cover all of that, AS 4654, rather than trying to cover it all in the NCC for commercial classes. They just let the standard take care of it. And that would have instructions about how to roll it out, how to overlap it, how to tape it and connect it, because it comes in sheets, if you like, or rolls that are narrow. It doesn't fit a whole house or a whole building all in one go, so you've got to overlap them and things like that. So there'll be manufacturer's instructions and standards for that. Just add another row in your checklist, F1.4, external above ground membranes, and then put as per AS 4654, part 1 and 2. typically for framing structure that will be occurring. It's probably not on the checklist because we've got solid construction proposed. The massing of this sketch is probably solid concrete or blockwork, so there's no requirement to put the sarking or the sisolation over it, but like Sandra said, concrete is porous, so it would still have to be sealed. It would still have to be impervious. So we'll probably come across that.
Single skin blockwork, as we do quite commonly in Darwin, and especially in apartment buildings. How we achieve waterproofing on the walls is that we paint the external side of the wall with a sealant. So it's a paintable membrane that we're putting on the wall for waterproofing.
How did you go? Excellent. Well done. Excellent. Going okay, Sharon? Excellent. Everybody's doing really well. Good job. All right, so roof coverings. It says a roof must be covered with either concrete roofing tiles complying with the Australian standard, except in cyclonic areas, which is a different code, or terracotta roof tiles complying with the standard, or except in cyclonic areas, a different code. These are our choices. I move on quickly because there are more. Or cellulose cement corrugated sheeting, so that's the new version of asbestos corrugated concrete sheeting. Metal roof sheeting, and it's standard. Plastic sheet roofing, and it's standard. Or asphalt shingles, and it's standard. So they're all the different types of roof coverings that you can do. So it's about keeping the weather out, sealing up the roof and making sure that it's closed. And the Australian standard has the same principal effect as in the other standard, where it gives you all the extra information about overlapping and things like that. So again, we have our deemed to comply manual that refers back up to that if we need. But I would perhaps, hey, yeah. Yeah. Sarking, yeah. I suppose it's, not to worry. So I would probably add F1.5 roof coverings, but I probably wouldn't go into all that detail. This is the one that we typically use, D. So I would put F1.5 roof coverings required, and then I'd put bracket D, metal sheet roofing complying with AS 1562.1. So there's a few rows missing there. Our roof is in fact a big concrete slab for this particular design. Even though there's a fly roof on the top that's clad in metal over the top and on the sides, the actual work is being done by the concrete structure. It's not referenced as a roof. It's not typically something that you would specify. This is really talking about framed roofing that then is clad with some sort of a skin and all the different types of skins that you can use. But if you just plonk a great big concrete slab on the top of your building, that would act as a roof as well. But it's more of a sizable structure rather than something that they would need to worry about waterproofing. It would just need to be sealed. And there's a big note on here already about that. F1.6 is sarking. So weatherproofing the roof and walls must comply with AS 4200. Add that one on as well. So just write F1.6 sarking and then as per and the standard number 4200, parts 1 and 2. Doing well. Just chipping away, chip, chip, chip. This kinds of information goes in the notes on plans generally, yep. And then it just covers you to make sure that everything you've drawn and written gets further referenced where it needs to be to Australian standards. So it's just pages of text that are at the end of your drawing sets. Alright, so F1.7, which is the main one we were looking for, is with regards to waterproofing of wet areas in buildings. So it says in A, in a Class 2 building, building elements in wet areas must be water resistant or waterproof in accordance with table F1.7 and comply with AS 3740. So if I just go to table F1.7, it'll look very familiar because it's the same table that we found in the Class 1 and 10 volume. So without even reading it, I could probably tell you that the shower will have to be 1.8 metres from the source of water, above the bath and basins and troughs 150 millimetres, the floor to within 150 millimetres up, all the penetrations, it's all the same notes as we covered yesterday. Now I've got that written out just on the left hand side, but you might want to put that down on the right hand side. You might want to update your checklist on the left hand side and then just put required next to that. So the floor has to be water resistant, 150 millimetres above the bath vessels, troughs, laundry, floor. The floor waste is required, and there needs to be 1.8 metres and penetrations in the shower.
How we normally cover this in a typical drawing set is that we would have a sheet that has details of all the wet area details, and we would add that in as a detail sheet to your drawing set, giving clear instructions to building construction companies as to how they're going to waterproof the wet areas. So later on in the year we will develop up that detail sheet for all the wet areas. For now it's enough to say that it's required and what code we need to comply with.
So for the shower, the floor and the walls have to be waterproofed to 1.8 millimetres from the source of water and penetration. So anywhere that you're getting into the floor or into the walls, they have to be sealed as well. For the wet areas, the floors have to be waterproofed, water resistant. If we have a bath, it's to 150 millimetres above the vessel. So for the section that the bath, if it's freestanding, that's a little different, but if it's up against a wall, then it's 150 millimetres above the vessel everywhere it touches the wall. For the laundry trough, the same. (150 millimetres above the vessel). And the laundry floor, so wet area floor is the same as the laundry, and a floor waste is required for the laundry. And the hand basin and the kitchen sink.
Did anyone watch the block last night?
Was it on, was it?
They were painting a wet area with the blue gunk. Well,
Get out of town.
But it was on as I was getting my son ready to go to bed. And I went, oh, I hope students are watching this. And they were...
After we all said don't watch the block, that was exactly what they...
Exactly what it is last night.
You wouldn't read about it. Ah, that's great.
I did think when I saw that last night, and they talked a lot about the different materials.
They are trying really hard to do the right thing. I will give them that.
So I was like, oh, you know, I know yesterday we said blocks, you know, it's not great. It doesn't really show you much about the construction techniques or doesn't tell you anything about design really.
No.
But it does talk a little bit about materials,
That's true.
and especially commonly used materials in Australia. So since we're going to be moving on to lots of materials next week, maybe you should tune in.
If you've got nothing better to do this weekend, you can binge on episodes of The Block on Catch Up TV and
Try and
call it research.
catch the names of the materials they're using, the brand names. And
That's actually pretty cool advice. Yeah, I'll have to give you that. And I will give them 10 points for trying. They are trying to show that they're compliant. They have had a couple of instances where what the competitors have done has been very bad workmanship, and the inspectors have made them pull it out and redo it. That's mostly to make more drama and hysterics in the show as well, but in the end they do have to be compliant, I suppose. I can't believe they did that just after we've been talking about it.
I was walking past, I wasn't even sitting there.
It stopped you in your tracks, did it? Oh my goodness. Doing well, everyone. I think we're tracking quite well time-wise. Excuse me.
So, in most wet areas, we'll see, will be tiled over this area. So you you might see that strip of tile, just above the sink or above the bath. It doesn't really tell us we have to tile those areas. It says we have to waterproof them. And the blue gunk is the waterproofing membrane. So if you're happy to look at blue gunk paint, then you don't necessarily have to tile, but most people aren't. So you generally see the minimum amount of tiling is to do with the requirements for the waterproofing is all connected.
Yeah.
And why I'm telling you that is because as a draft person, you will, and we saw it in the Class 1 building, you'll often be asked to draw the internal elevations of the bathroom and the extent of tiling. And so your minimum requirements for tiling are basically the minimum requirements for waterproofing.
Because it covers up that awful stuff. Mm. You can use other products as well, not just tiling, I suppose. There's
PVC lining.
plastic sheets and different products. There's sheetrock. It's called White Rock, I think. There's like a commercial product that you see a lot in hospitals and things that's completely impervious. So, and that actually will bend around corners and things. It's quite nifty. So you don't have to have joins where bacteria can grow and go out and things.
If you go to RDH, for instance, they don't tile all their wet areas. It's all like a vinyl, plastic, and then put up the walls again. So that covers.
Yep. And these days, with the way fashion is moving with bathrooms, people are tiling their entire bathrooms, not just the extent of where the waterproofing has to go. Whereas before they might just have a skirting and then paint the back walls where the door is and the towel rail and things. Whereas now you're seeing beautiful porcelain tiling the entire room right up to the ceiling. All right, F1.9, damp proofing. So except for a building covered by C, which is down here, C, which is a 7 or 8 building, so they're less interested in weatherproofing warehouses and car parks. But except C, moisture from the ground must be prevented from reaching the lowest floor timbers and the walls above the lowest floor joists, if we had that kind of construction. The walls above the damp-proof course, if we have that, and the underside of a suspended floor constructed of a material other than timber, and the supporting beams or girders. So that's exactly what Sandra was talking about, making sure that moisture in the ground doesn't come in connection with the structure that's sitting on the ground, because ground is damp, just because it is, always. And you don't want that moisture from getting into your structure. So you need damp proofing. And we talked about a membrane, so it's simply just plastic. You've probably seen it on building sites. It can sometimes be orange, sometimes it's black. That kind of depends on the heaviness, the weight of the plastic. And they use it underneath the concrete before they pour it onto the ground. So you'll have the foundation, which is the dirt, then the plastic, and the reinforcing and things, and then the concrete goes on top.
But it's not there just to contain the concrete. It's there for the life of the building.
It's not like a pool for the concrete, yeah. And if you're lucky, you can see it when you dig out next to a concrete slab if you want to know it's there. So sometimes you'll have a client that might come to you, this is particularly in Class 1 and 10 residential projects, where they've got an external space, a veranda or a carport or something like that, and they want to make that part of the inside of the building now and build walls under the structure and sort of move into it. But you can't have habitable spaces where there's no damp-proof membrane, and you don't have to have the damp-proof membrane where there's no habitable spaces in a Class 1 and 10 building. So you don't often have that plastic membrane underneath the concrete slab that's already there for the veranda, so you can't automatically build it in and move in. If you can dig up the side of the dirt and see the plastic, then you can get confirmation that it's there. But if you can't get that confirmation or it's not there, you'd have to lay more plastic and add another topper slab. So Sandra mentioned that concept yesterday, just a 50 screed, so just a little bit more concrete. It would have to have the plastic beneath it to prevent any rising damp that was coming up from getting into the space where the people live. That can be a problem because then it shrinks your height, your overall space, under what is probably already a low veranda roof. So you get squeezed and then you're not compliant with the room heights of the NCC. So sometimes building in the veranda is just not possible because it can't be compliant with all the different aspects of the rules and regulations.
Yeah, it's true of building underneath it. A lot of
The elevated houses. Yeah.
Well, people think because there's already maybe a concrete slab there that they can use that as a floor. That's not the case because of damp-proof membrane that's required.
So F1.9.
That was built in downstairs, and the height, the downstairs height was 2.2, but it was all kind of certified. But even in bedrooms and things, it was 2.2 high.
And it was their size.
I'm pretty sure it was, yeah.
So they probably lied about the bedroom part on the plans and probably said it was something else. Yeah.
That was because we didn't see it at first, but you can't
Yeah.
see ceiling fans.
Yeah, no, you
That's
can't.
the reason we're kind of like stuck.
Yeah, no. It does sound a little bit like they've cut some corners there. It's quite common.
So I have that scenario at my house. We've got a granny shop built onto the elevated part of the house, but on paper it's storage.
Yeah. And your other option is to dig it out. So you can take the old concrete away and lay the plastic down and put the new concrete down. It doesn't take away your height, but it's a bit more expensive. And if you need that extra height under an elevated one, you can actually drop it down even further, but that's an issue with drainage, so you have to be careful with that. So everything you change creates another issue you have to solve, and depending on what the problem is and what the solve is, can determine what your design decision ends up being, which is a bit like what we're doing here. We're investigating all the rules and regulations so we can make a decision about what we're going to compromise on and what we're not going to compromise on. It's quite tricky. So I'm just adding F1.9 damp proofing. And it'll be F1.9A, and then the third option, III, because it's the underside. It's not really a suspended floor, but it's a floor constructed of another material other than timber. There's some information in section B here that says where that damp-proof course is provided, it must be a material that complies with AS 2904 or an impervious sheet material in accordance with AS 3660. Now don't quote me, but AS 3660 sounds very much like the termite code. Let me just double check that, because you can sometimes use the same product to also prevent termite attack, but it might not be. The typical one does it? But yeah, it is termite management. There you go. So you've got a couple of options. You can have just AS 2904, which does the damp proofing, or you can do one that does that and termite management. So they're special. It's called Home Guard. There's a product, there's probably quite a few on the market, that you can have as a damp-proof membrane to prevent moisture, but it also keeps termites out as well. So it does double duty. F1.10, damp proofing of floors on the ground. If a floor of a room is laid on the ground or on fill, moisture from the ground must be prevented from reaching the upper surface of the floor, which is exactly what we were just talking about. Now we've only got the car parking on the ground floor, but there are some storerooms. they are going to be less than 10% of the use of the building, so they're going to get treated the same way as the rest, class 2. So we would probably need to provide damp proofing underneath those storerooms because they're not just a warehouse or a car park or anything. Storage typically doesn't need damp proofing, but it's going to get treated the same way. So in this instance, we would. So F1.10, damp proofing of floors on the ground is required of our ground floor slab down towards the storerooms. So weatherproofing is not, so it says, what have we got here? If a floor or room is laid on the ground or on fill, moisture from the ground must be prevented from reaching the upper surface of the floor and adjacent walls by the insertion of a vapour barrier in accordance with AS 2870, except damp proofing need not be required if weatherproofing is not required, so class 7 and 8 where weatherproofing isn't required, or if the floor is the base of a stair, lift or similar shaft which is adequately drained by gravitation or mechanical means. So we don't have to worry about the stair area or the lift shaft for weatherproofing.
And that's because it's generally a lift shaft. If all the mechanics are held at the bottom of the lift shaft, it's generally pumped. It's drained by a pump because it's at subsoil level. Mm. And the slab underneath the storage rooms is going to be poured independently of the car park slab because the loads are different and they will settle differently. So there's an opportunity there during construction to put the damp-proof membrane just under that small piece of area. So it's not really an over difficulty for the builder. And I suppose we need to think about too, from a design perspective, what you need to think about too, and those storerooms are generally going to be used by people who obviously they live in the apartments above. And those types of storerooms are generally fairly full of things, and the door is closed and there's not a whole lot of ventilation in there. When we think about a big warehouse where maybe people are working in there, you know, they're working during the day, they've got all the roller doors open, there's like breezes blowing through, that floor will never become damp because it's got so much ventilation to dry it out all the time. But a very small enclosed storeroom that's jam-packed full of things doesn't have that same access to ventilation, and so it's probably a good, from a design perspective, even though it might not be fully required by the NCC, from a design perspective I would certainly be putting a damp-proof course in there so that moisture doesn't come up through the floor and just cause mold growth in a storeroom like that.
Good point. So F1.11, provision of floor waste. In a Class 2 building, a bathroom or laundry located at any level above a sole occupancy unit or public space must have a floor waste and be floor graded to the floor waste to permit drainage of water. So we already mentioned that earlier. I kind of jumped ahead there a little bit. The wet areas require waterproofed floor, and in the laundry, a floor waste is required. So it's a laundry, it says bathroom or laundry. I suppose there's an expectation that typically in apartment complexes you don't get a separate laundry. It's typically included in the bathroom. So
I think it means both. I think if you've got a bathroom and a laundry, you need to provide a floor waste.
It's a sort of an and/or scenario.
Well, I would mark that on my drawing. I would put
Yeah.
a little SW, floor waste, in my wet area.
It's normally just a...
So that when you go to draft, that, you know, when you go to do a plumbing or, you know, your wet areas layout, that you remember to put the floor waste in those areas.
It's usually just a circle with an X in the middle to illustrate where the drain would go and the abbreviation FW next to it. So you can add that to your legend. I'll bring the drawings across and help you point out where they could perhaps go. Oh no, just point it out. So we've got our bathroom here. The idea is, and we talked a bit about this yesterday, the idea is that if any of the appliances in the bathroom or laundry flood, or for some reason there's excess water in the room, the idea is that the water goes down the drain instead of out the door and into the building. So the floor waste needs to be in front of the door. A bit like a smoke detector has to be in front of the kitchen, the floor waste needs to be somewhere between where the water can come from and the doorway. So pretty much right there, right in the middle. And then you typically fall the whole room towards that floor waste. So right in the middle, almost where the writing is for the bathroom and the laundry. So it's just a little circle with an X marks the spot and FW as a floor waste, and then you can add that to your legend.
Britain and Ireland, we don't have floor waste at all.
Don't you?
No. We deal with this problem in a bit of a different way. So this is a bit of an insight. Maybe in Estonia the same. Do you have floor waste in Estonia?
No, I don't think that's true.
Yeah.
I know there's one in sauna.
Oh, fair enough.
You definitely want one in the sauna.
There's nothing in our NCC about saunas.
No.
Go figure.
Whatever I want.
It's a real problem.
Whatever you want in the sauna.
We've got bushfire zones, but no
When you
saunas.
buy a wash and basin or a bath in Britain or
Oh, they
Ireland,
have the
they have a
slide at the
little
back.
hole in the
At the back,
appliance
yeah.
itself, basically. So they've got, obviously you can fill the bath up to a certain level, and then this is like an overflow. So if the bath is flooding and somebody's let the tap on by accident, the water will automatically go through the overflow and through the existing
Back down the
plumbing
drain.
system
Yeah,
back
right.
down the drain.
But don't we have the same here?
Yeah, a lot of the stuff that not in a bath, I've never seen it in a bath, but I see it in the occasional hand basin.
Yeah, yeah.
Occasionally.
Because it's come from a manufacturer from overseas.
Yeah. If you try filling it up and see what happens, you can see it go down and you can hear it go through the drainage. Yeah. That's what it's for. Overflow. Yeah, yeah. No, it's all good. I get you. It solves a puzzle you've had for a while. That's terrific.
In Taiwan, have they got floor waste in the floor?
I don't know why about the floor, but we will fill the hole.
Oh, the overflow.
Yeah, I think it's quite an Australian thing, the floor waste.
Yeah.
Come across it before.
Some of the designs in the bathroom in Indonesia, usually there's a little gradient towards one side of the wall, and they have like a little drainage.
Yeah.
Channel,
That's
yeah.
a little
Right,
channel.
okay.
That's actually built in, and it goes outside the house.
Right. Ooh, that's a bit complex.
Yeah.
In one of the,
Little hole
yeah,
in the wall.
one of the floor waste in the laundry I lived in didn't go into the system. It just had a little exit out to the side of the house, and it just had a little frog mouth flap on it just to stop frogs and, vermin and things from getting in. Yeah.
We didn't have that, so we just like a hole in the bottom, and both in the bathroom as well.
Yeah.
But
Just
it's
an exit.
very old.
Yeah.
Yeah.
I think the downstairs is probably before.
Yeah.
The floor waste is supposed to be charged, and plumbers will talk about this word being charged. So what it means is that the floor waste itself can't sit at the end of the line. So if you can imagine the floor waste is here and the pipes running down to outside. If that happens, a lot of the odours from this system can come back up through the floor waste. So that what they want it to be is charged. So what they'll do is they'll connect, say, the wash hand basin is over this side of the room. They'll connect the wash hand basin through, so the water, all the water when you wash your hands goes down through the pipe and washes out that floor waste pipe work, while it goes back on to be discharged. Because if you leave the floor waste sitting on its own, it can tend to be build up a bit of grime and dirt. Because usually water doesn't go down there. It's really only for emergencies. So if you ever do find your floor waste smelling, just chuck a bit of water through the floor waste. Hope that it's connected properly.
So in the other units, just in the laundry, right in the middle, and in the bath, probably right there in front of the hand basin and the bath, before it gets out the door.
We tend to locate them very centrally.
Yeah, right in the middle.
Yeah.
Except like Joanne was saying, where the whole room, and we mentioned that yesterday, now with big tiles, they need to fall the whole room, so it would be a completely different scenario. In this instance, it might go here. You might have 2 falls to a drain in the middle. There's a single hole under there. It's just a whole grate. Yeah. And within that system, it falls down to the hole. They're expensive too, those drains.
Interesting. Is that like a shower screen bath?
It's probably, it might be a shower screen with a bath, or it might be a bath with one of those screens above it you can sometimes get.
I would suggest a
Bit of an unusual picture.
without a bath.
Yeah, it's just
called a
bathroom.
bathroom.
Yeah, agreed.
And it's a double shower.
Yep, you're probably right. But you can sometimes get screens above baths.
Yeah.
It's pretty unusual because there's a shower over the bath and they want to keep the water in.
And often if it's a family bathroom like that, they'll have like a double shower, but it'll be a very low bath so that you can see there's a child in there or something like that.
Yes. Quite right.
Yeah, usually the wastewater goes into the plants because my shower is in the middle, they have like a pipe that get into the
into the garden.
Irrigation.
Yeah, right. I think we have an issue here. That's not too big a problem, but a lot of people would like a bathroom that's sort of outside, like a Balinese style bathroom. That's quite popular. What you have to make sure of is that the floor waste you have to provide doesn't capture rainwater. The certifier won't allow rainwater to go down the floor waste drain because you will make too much water going into that system and it can't cope. So you'd have to roof it so that you're not open to the sky. Just have to be sufficient roofing to prevent inundation of the floor waste from the sky.
So we have two systems. We've got our storage system, in which all our waste water goes into our storage system, and that includes from wash and basins and showers as well, and from our toilets, of course. And the other system is your stormwater system. So they're two separate systems, and your sewer system is a closed system, so all the pipes are closed. But our stormwater system isn't, it's an open system, so we see open drains all around Darwin, you know, that they're stormwater drains. And it's rainwater, it's clean water, it's not come from anybody's toilet or anything like that. So what they don't want to do is overflow the closed system, the sewer system, with rainwater, with stormwater. We want to keep the two of those sources of water separate.
Subfloor ventilation, F1.12. So we don't actually have any subfloor spaces. Our lowest floor doesn't have any space beneath it. I mentioned yesterday about making sure that you've got ventilation if that is the case. That isn't the case for us. So just having a quick look that that's there, but we don't have to put it on our checklist because we don't have any subfloor ventilation. But there's minimum ventilation calculations for subfloor ventilation for the future if ever you need it. Pretty rare up here, I must say. They've got a whole bunch of relative humidity that goes with it. Glazed assemblies. We don't really have any glazed assemblies as such. We've got some windows, but we don't have any massive systems or assemblies or curtain walls in this particular design. If we did, there would be some compliance requirements with regards to waterproofing. Now, I don't know if you've seen, there's a couple of series on YouTube and things like that about mega structures, and one of the really big, innovative tower structures in Dubai has a special new innovative window assembly, and they had to test it, and the footage showed how they were testing to make sure that that assembly was waterproof before they put it into the building. So there was lots of testing, and that's quite common for big buildings to pre-test the construction system before you use it. So they were just making sure. That's not the case for this, but we would have a standard that would have to make sure that it was waterproof, but the standard windows would be installed just the same as they would be for perhaps a Class 1 and 10 building.
So does everyone know what a curtain wall system is? What we're talking about there? Okay. Sorry?
blinds, yeah.
Curtain wall, yeah. And no, it's not blinds. So basically, if you've got a large building and the structure of that building would be column and beam construction, so the walls are not structural. Okay, so say for instance this building, we've got columns there, and so it works on a structural grid, and that's what's holding the roof up. So what do we make the walls from, and how are the walls supported? So the walls are not holding up the upper floors of the roof; they're actually just fixed to the side of the structure, and that's really what we call a curtain wall. It's a screen wall or a curtain wall. That provides an envelope to the building, but it's non-structural. Curtain walls are always non-structural. Who knows the Charles Darwin building in the city? The
CDC building. Yeah.
Shaped building that's right.
Quite new, above the Paspali shop at the end of the mall. I.M. Pei was the architect. Yeah. So it's
probably one of the newest
in section. In section, it kind of looks like that. A little bit wider. In blue, yeah. Just a big government building.
Right at the top of the mall, right across from the tourist information office there. So that building, if you look at that, it's completely glazed. You know, it's glazed from floor to floor. And so what they've done is they've got these big panels of glazing and they fix them to the floor slab, and they span usually top to bottom. Sometimes they can span side to side. but that's a curtain wall system, something that's just fixed to the structure of the building, giving you a wall system. So when we say this is the waterproofing for curtain wall system, it's very much depending on the manufacturer of that system, how it's waterproofed. You know, how is the glass supported? It's supported by a series of usually steel, mullions and transoms. Can be made of other materials, but generally steel. And they're giving a secondary structure to the building, and they're holding the glass in place. But they're not taking the weight of the roof down to the ground or anything. They're not the primary structure of the building. That will be done by columns and beams. Yeah. So that's what curtain walling is, and that's what this clause is referring to. Then, how is that system waterproof?
Yeah.
And you find that glazing manufacturers and curtain wall system manufacturers, which we have quite a few in Australia, they'll be very conscious of this clause, and they will be doing tests on the waterproofing of their systems.
Question, I heard you mention transom. Is that for obviously the fireproofing, fire?
No, it's just a horizontal part of between windows.
For the curtain wall?
They're generally not fire rated unless they're within the 3 metres of the fire source, like the standards require.
So how they spread up?
Oh, no, that's a spandrel. Yeah, the transom is, so a transom is just a horizontal member,
Yeah, I was talking about
but the spandrel's a bit different. Yeah. So it would probably need to be fire rated for that. Yeah, quite right. But that was about occupied sole occupancy units. There's nobody sleeping in the office building, so it's a little different. Yeah. So you're probably not required to have it. I'm sure there's an element of fire ratedness in those curtain walls, but it's probably not needing to have that spandrel separation because there's not people sleeping in there. Yeah. Back to those activities of use.
They're building another one?
Yeah, next to the building next to the main shop.
Okay.
Oh, yeah.
They are tearing it down.
Yeah.
Yeah, and there will be a curtain wall system up to level 9.
Wow.
But the spandrel is between the
Okay. Yeah, so they're going to have some fire separation. Yeah, right.
Very good.
And that will create shade as well.
Yes.
Yeah.
Well, that's the other thing in Darwin. We don't do so well with curtain wall systems. We don't get any shade. They generally are flush with the outside of the slab. Sorry, Sharon. 2 levels only of curtain walling.
Yeah, right.
Yep.
There you go. Apparently the architect who did the CDC building for us did not want to put those shade awnings on. He was very cranky about that. I predict because he already had that design up his sleeve and he'd already done all the calculations for it, because I've seen another building overseas just like that. So when he bid for it, we took it, but it wasn't the first time he had designed or drawn that building. And we wanted to add the shade. We've got little shade structures that stick out at each floor, and that would have been over and on top of what he had already calculated for wind loads. And so a bit of extra work, and apparently he resisted because he didn't want to change the aesthetic of the design. Like, it's perfect the way it is, and we wanted to add this extra thing stuck on.
Building glass houses in Northern Territory in Darwin is not the best idea.
No, even though they're beautiful. All right, F2, sanitary and other facilities. Similar to what we covered with the class 1 and 10 yesterday. So F2.1, sanitary and other facilities for class 2, etc. must be provided in accordance with table F2.1. And there's table F2.1 right there. Within each sole occupancy unit of a class 2, we must provide a kitchen sink and facilities for the preparation of cooking of food, and a bath or shower, and a closet pan, and a wash basin. Laundry facilities provide either in each sole occupancy unit clothes washing facilities comprising at least 1 wash tub and space for a washing machine, and clothes drying facilities comprising of a clothesline or hoist with not less than 7.5 metres of line, or a space for 1 heat-operated drying cabinet or appliance in the same room as the clothes washing facilities. Note, a kitchen sink or wash basin must not be counted as a laundry wash tub. So there's an extra layer on a class 2 building because the sole occupancy units don't have connection to the ground. You don't typically see an external line for hanging wet clothes on to dry in the air. That's pretty unusual. I know of some class 2 buildings that have a separate ablution block. It's a pretty old-fashioned design, so this is in an older suburb of Darwin, where they have a separate room where there's 3 or 4 washing machines and a couple of clotheslines outside, the old Hills hoist, Australian invention. Typically what you'll see is a space for the washing machine and a space for the dryer, and they may or may not be provided within the bathroom, typically. But there'll be a small hand tub in there with the laundry.
We'd be there, looks like, if you wanted to have shared or sharing before.
There's a little note here about a separate laundry, about there being a separate laundry for each 4 sole occupancy units or part thereof. So it looks like you have to have, if you've got more than 4 sole occupancy units, you might have to have more facilities.
If you're not providing
Then,
it
yeah.
within the department and
Yeah.
you want to have a shared facility, you can do that, but it is quite an old-fashioned idea.
Yeah.
And I think a lot of people want to have their own private laundry.
Yep. I did a design with some past students where we designed a Class 2 building, and I encouraged them to still have a provision for a clothesline out on a balcony that didn't have line of sight, because it's the look. People don't want to see clothes hanging or over the balcony. That's a bit of a no-no in a lot of body corporate rules. They don't allow you to hang clothes over the balcony or towels or things like that. They want that nice, clean, crisp look. So they don't want clotheslines out on the balconies either. But I worked it out so that it was screened. Because it's nice to be able to dry your clothes out in fresh air rather than having to do it mechanically. It's such a waste of energy. Yep.
When we lived in Perth, we lived in an apartment block, and I remember actually like a note coming from body corporate saying that you're not allowed to have like any clothes.
Yeah, don't have any clothes areas or anything out there. Seems a bit unfair, doesn't it? It's such a huge amount of energy wasted when you use the dryer, but it also creates hot air, humid hot air, because it's taking the moisture out of the clothes and expelling it. And then you're putting that into your living space, in the laundry, in the bathroom and things. So you've got to have the mechanical ventilation running or the window open to let that moist air escape. So unless it ought to be vented to the outside from in there, but it often gets blocked up. So reasonably straightforward provision of sanitary and other facilities for our Class 2 buildings. There's some notes on the checklist that are common notes that you would see on drawings. They're just nice to have. I thought you'd like them. So Part F 2.1 has dealt specifically with the residential classes of commercial, so 2, 3 and 4 parts. And then the following from there, and we'll come to this later, there's a different clause about how to determine the number of occupants and facilities. So we hinted at that yesterday, that there's a whole table about that, so we'll get to do that later. And then it's facilities in a 3 to 9 building. So we won't worry about that too much right now. We'll come back to that
The only time
later on.
apartment building that you might have to look at that is this, a lot of apartment buildings have swimming pools here in Darwin, and often they'll put one unisex toilet facility close to that swimming pool.
Yeah.
But we assume for apartment buildings that, most of the occupants and visitors even will have access to the private ablution facilities within each apartment. Not really thinking or considering putting public facilities in the apartment building.
No. Here's the clause for it, F2.4, literally stumbled across it as you were talking. And it says here for Class 2, where sanitary compartments are provided, so if you did, then you would need at least one disabled compartment in that facility. So yeah, that's quite common. Just one unisex disabled, combine it all together. Yeah. And then there's construction of sanitary compartments, so everything other than early childhood centres. Early childhood centres have unusual dimensions because their occupants are so little, so they have little toilets, which is so cute. So this is about the doors having heights for privacy. This is about public, so not necessarily the sole occupancy unit. So again, we'll come back to that. And the swing, health and amenity, microbes, and the airlocks and everything, that will come back into commercial buildings, so we'll circle back to that for the AT3. It's not necessary in the sole occupancy units. All right, F3, room heights. So we've got the height of rooms and other spaces must be not less than, in a Class 2 building, for the kitchen, laundry or the like, 2.1 metres, so same as a Class 1. A corridor, passageway or the like, 2.1. A habitable room excluding the kitchen, 2.4, same as a Class 1. Or a room or a space with a sloped ceiling or projections below the ceiling line, like an attic or other rooms, 2.2 or 2.4 respectively. Oh, go back.
So what's our standard habitable room ceiling height? 2.7 in Darwin?
Because that's heat. If you take the heat out from air flow.
You got it right.
We got a new class member over here. Yeah.
So fan.
Oh, yeah.
So you can't have a ceiling fan at 2.4 at height and then have to be room, so we're going to allow the extra 100 mil and the fan is always, you know,
Wise.
influence here for a bit of coolness, or provide fans at habitable room. I'll have to provide them in wet areas too.
Oh, yes. The fan in the bathroom is such a luxury in the wet season. If you've not got the air conditioning on, fan is a godsend.
Not too many of us have air conditioning in our bathroom, so
No.
the least you could do.
Yes, exactly. All right, how are we doing? Oh, goodness, so close. I don't have anything listed against light and ventilation. I expect, so provision of natural light must be provided in Class 2 buildings to all habitable rooms. It will probably say how much, and I expect it'll be the same as a Class 1 building, being 10%. Natural light into a room, that's borrowed, where's not borrowed? Natural methods of extent of natural light, required natural light must be provided. Oh, there it is, the same 10%. So it's exactly the same note as yesterday. We want 10% natural light to habitable rooms. And I expect the ventilation will be exactly the same, 5%.
So I suppose the borrowed natural light can come into play in some apartment designs I have seen where they do have internal rooms as bedrooms and they're borrowing natural light from a corridor space, so the light. Not ideal.
It doesn't sound very nice. No. It'd be all right for a study that was a guest room for a couple of nights, maybe, but as a permanent bedroom, to have no natural light except for borrowed light would be a bit... I have stayed in a guest room that was a study that was internal. Yeah, I remember now, and it wasn't very pleasant. Yeah. Natural light borrowed, which we covered yesterday. Ventilation. Habitable rooms, obviously. Natural ventilation, 5%. There it is. So light and ventilation. Clause F4.6 for natural ventilation. Clause 4.2 for natural light. We can borrow ventilation the same as we can for a Class 1. And then the same note as yesterday as to restricting sanitary compartments from opening into kitchens. So that's clause 4.8. We need to, I'm just going to write do better. I've got the notes. So I've got all the notes.
Yeah, great.
I just need the clauses.
Yeah.
Just some extra rows there. So if you do have a sanitary compartment opening into a kitchen, you have to have an airlock. And that's F4.9. We don't have that issue, so we're okay. So there's a little note here about car parks, F411. every story of a car park except an open deck car park, which is what we do have, so this doesn't apply to us. But if we had it all closed in, we'd have to have a system of mechanical ventilation complying with AS 1668. So you can imagine the gas fumes from motor vehicles, particularly if it's a busy car park and everybody's sitting in line waiting to find a car park, those exhaust fumes would really build up. So you'd have to have significant mechanical ventilation for that, or a system of natural ventilation. Those screens that we've got at the waterfront car park are probably quite sufficient for the ventilation that you need for there. It's not closed in fully.
In my design experience, about 50% opening gets you out of this clause.
Yeah,
So
that's
if you
not
get,
too
about
bad.
50% of your car park that has natural openings for natural ventilation, you're not required under AS 1668 to comply or to provide mechanical ventilation. The other thing is that most buildings have found this is a huge area where they can make energy savings, because if you install the mechanical ventilation system the old-fashioned way, it just ran every day, and there could be 2 cars in there all stopped for the whole day, just parked up, and they were running all this mechanical ventilation, which was unnecessary. So now they generally install that with CO2 sensors, and it only is kicked in on when there's like exactly that scenario.
When it builds up.
So really, we only have an issue in shopping centre car parks where on Christmas Eve there's like 50 cars all just driving around in circles with all their exhaust fumes getting trapped inside.
The tunnel that goes through near the I think it's the M1 or M4 highway in Sydney. The ventilation there, they need to improve that, because I used to ride a motorbike through there to pick out traffic. By the time I get to the one end, I'm like,
You can barely breathe. Oh, Lord.
Carbon monoxide as well.
Yeah, that's
really
nasty.
Dangerous. It's very dangerous fumes.
I get so nervous when it comes to caravans and boats and enclosed spaces and people in sheds and living in sheds and then putting the barbecue on and burning oxygen and producing CO2. You just go to sleep and you never wake up.
Yep.
So dangerous. So dangerous.
So there's probably at least one family a year in Ireland who gets killed in their house from carbon monoxide poisoning.
Yeah, wow.
Due to lack of ventilation in the spaces and heating systems. And generally they all just go to sleep and they just never wake up.
Yeah, yep. I went travelling with my dad in a recreational vehicle, an RV in the US, and they come with monoxide monitors inside them, and we had a stay inside day. It was really wintry and we were exhausted, and it was just like a nice cozy day to bake cookies and read the paper. It was terrific. And about 2 o'clock in the afternoon, the thing started to beep, and so I started opening the windows, and Dad just took the alarm and went outside with it and shook it.
In the fresh air.
He's like, "That's okay now." I was like, "Dad," because it's quite cold. It's like opening the windows. It's a shocker.
Put the alarm on.
Just put it outside to stop it from beeping. It's a disaster. F4.2 is about exhaust ventilation in commercial kitchens. So we don't have one in this project, but just be aware that that's there as well. All right, we better stop for lunch. We'll just do the last part, F5, straight after lunch. Well done, everyone. That was not exciting, but quality work. The real work of drafting. So well done. Ended up finishing light and ventilation, didn't we? I kind of skimmed through that pretty fast, but it's the same 10 and 5% light and ventilation as yesterday, so I cut a little corner there, but hopefully you're all okay. If not, just come and see me. F5, noise and transmission and insulation. Insulation, however you want to say it. We had a little bit of a head start on this yesterday when we looked at having Class 1 buildings that are connected and adjacent to one another. This is kind of in a similar concept to that, where we have to protect each sole occupancy unit from the noise, sound transmission of the occupancy. Now we've got 3 units on each floor. 1 unit is actually physically separated. They're not connected at all. So we don't really have to be too concerned about that. But there's that 1 and 2 that are mirrored of one another that have a adjoining wall between them, don't they? And we talked about the fire rating level of construction earlier in the piece last week. So this is just the sound aspect of that. So part F5, and there's some sample notes on the checklist rather than clauses, so we might end up updating this a little bit, but there's some sample notes on the checklist for you already. I'm just going to skip straight past the performance requirements and get to the main deemed to satisfy clauses. So the first thing you'll see is the application of the part. These deemed to satisfy provisions apply to Class 2, 3 and 9C buildings only. So if ever we are investigating the clauses for a different class than that, we could skip this whole section. We are currently doing Class 2, so in the past where there's been clauses we didn't have to worry about, this is one we do have to worry about. F5.2 is about trying to determine what sound rating a wall needs to have. So this RW is a unit of measure for sound acoustic travel. I don't know a great deal about it, I must confess, it's beyond my area of expertise, but this RW, which is the sound reduction index, it's a bit like the same technique you'll hear in thermal unit measurement. R values are the amount of heat that stops being brought into a building because of the thermal resistance of the construction. This is a sound resistance. So I know R stands for resistance, but I'm not entirely sure what the rest stands for. So I do apologise for that, but don't feel like you have to know either. We're just going to look at what is required and then the suggested of the, weighting, and what is required of the construction to achieve it. The weighted sound index. Well, so good point, one, thank you. So the W is weighted, quite right. So it says here, comply with specification F5.2. So let's just go there and see what we can see. So there'll be a table. Let's go to the table because that's what we often want to know. Oh, okay, so the specification is listing the weighted sound reduction index, this RW, for some of the common forms of construction. So we've got 2 leaves of traditional clay brick masonry with a cavity of not less than 50 millimetres or glass wool insulation. And it's got a representative image on the right hand side, and that's RW50. Or you can have 2 leaves of traditional clay brick masonry with a cavity of not less than 50 millimetres or 13 mil cement render on the outside. Again, RW50. So different construction techniques. We don't use either of those 2 techniques here because traditional clay brick isn't available here locally. We used to have a manufacturer here a long time ago, so you do see different types of brick sizes around on older buildings, but it closed down, and since then we've simply just gone with the concrete masonry that's available in a bigger size. The cost of transporting clay bricks here from interstate would be too great to warrant doing it, and most of them would probably break on the voyage, so we just don't do it. This one's clay brick with timber framing as a veneer. On the outside you've got the clay brick and then you have framing on the inside. This one's a skin on each side of framing and the masonry inside, but still the same acoustic protection offered. There's lots of different ways to achieve RW50. And then we've got single leaf with 13 mil render on each side, and that does 50 mil as well. This one here, this single leaf of 220 millimetre brick masonry is a different size. I'm a bit unsure why they've... So this is known as 200 series, these blockwork bricks. They're actually only 190 millimetres wide, so normally it would say 190. So this must be a different type of brick that's a little wider. A bit unusual. 110, 110. So masonry with render or just solid concrete block. So that one's a narrower section. So that one's external construction, it's bigger and holds more weight, and the half size is for internal and it's non-structural. So you can obviously use non-structural walls to do acoustic separation, but you'd have to fill every cavity with concrete for it to do the work. Then we've just got concrete itself. So 150 mil thick concrete panel. That's often precast and made off-site and then brought in and stood up. Very quick construction on-site. It's really helpful for where you've got a lot happening quickly and you can make a lot of the components somewhere else. Wait for the time to pass for the concrete to be fully cured and then bring it on site and construct quickly. There's a 200 thick concrete panel. That's a bit more like what I was looking for. There's 100 mil thick, 125 mil thick. It's got cladding. There's all sorts of different types of construction, and they've given us lots and lots of different ratings. Now here's one, 190 millimetre thick concrete blockwork. That's the 190 series or 200 series, 190 thick blockwork that I was referring to. It's 45. Now it hasn't actually stated whether that's full of concrete or still hollow inside. It looks full of concrete on the image, but I don't know necessarily that I would take that as gospel. We'll see. And 100 mil thick concrete panel, because 190 millimetres wide solid concrete is going to do a significant job for acoustic separation, and we have that structure between our two apartments. So it'd be 90 RW. This is a different material that you may not have come across before, autoclaved aerated concrete. It's just abbreviated to AAC, and you might cover that next week. They look the same as concrete, but they've got more air through the mix. It's a much lighter material, so it's sometimes easier to work with, but structurally it's just as stable. There's a company called Hebel that makes them. Hebel? 2 leaves, 1 leaf, and then we've got timber framing and steel framing. And that's quite difficult to achieve acoustic separation just on its own, like we were talking about yesterday. Just the framing and the cladding's not typically enough. So they've got examples here of different stud walls, 2 layers of plasterboard and some insulation in the middle. This one's similar, but it's steel, and they've got that full of that insulation or wool, fibre wool insulation in there. And it's usually fire grade as well, so it acts as both a fire rated wall, an acoustic wall, and security and privacy as well. Gosh, it just goes on and on. And then there's floor construction. All right, so we've got some of the R ratings for floor construction. We've got concrete, so 150 mil thick concrete slab with some furring channels. See these metal furring channels just underneath that allow you to have some isolated mounts fixed to the underside of the slab. That can be a way to line the underside of a floor to become a ceiling, and you can have quite deep furring channels that allow for services and ducting and things like that for wiring and down lights and what have you. And then there's some insulation between them as well, which would have to give some room around the lighting. 200 thick concrete slab with a carpet on underlay, so 50 RW for that. That seems a bit under, oh, not less than, okay. So it's more, but it's not less than 50. Sorry, I was looking at that figure and I'm like, 50 is a bit low. I would expect that to be sort of around the 110 mark. But it's not that it's more, it's that it's not less than. Autoclaved aerated cement concrete floors, timber with chipboard, timber with tongue and groove boards, and that's the end of that. Gosh, there was a lot.
So for this particular...
We've got 200 mil concrete slabs for the floors, and we'll have solid cavity filled 200 series blockwork for the partition wall. Yeah. That would be my recommendation, because it does so many of the things that we need it to do. It's fire rated, cyclone, it's privacy. No, it'll probably be rendered, plastered, rather than direct stick. And the reason why I recommend that, and you can choose to go against it if you want, but you can actually put glue on the back of plasterboard and just stick it straight to raw concrete like that. It will work, there's no problem with that, but Ants like it. It's actually really nice for ants to live behind. Yeah, because you've made a shape even with the glue. Yeah. But it's doable. Like if it's not, up on a second or third story, it's not likely to be an issue. So that's a good way of doing it. You can also batten and direct stick plasterboard. But for a rental property, it's not very hard wearing.
Yeah.
Like if you've got tenants who are a bit rough, might bump into the plasterboard with furniture or push bikes or, elbows, I exaggerate, but you get the idea. So solid plaster would be a much more hard wearing finish perhaps. Yeah.
So we're going to do with this.
Yeah, that'll be is that the floor?
No, this is, I think this is wall.
Let's have a look.
Yeah.
Just do a quick back. I just want to make a note on the plans.
Yeah, that one there.
Oops, too quick.
Down, that one.
This one?
Yeah.
Yeah. No, that's concrete, solid concrete. And the other thing we have to remember too is the MPA of concrete that they make blocks out of is different to the MPA of concrete you make a precast wall out of. So it's not much of a difference, I don't imagine, for acoustics, but it does have a bit of a difference structurally and fire rating and things like that. So we just have to be careful with that. So it's not going to be solid concrete. It'll be this 190 mil thick concrete blockwork, that one there. But it'll be full of concrete.
Did you say rendering as well? Maybe?
Well, it'll be plaster.
Right.
They were saying 13 mil as the minimum for plaster, weren't they?
Yeah.
It might be.
But the dimension here says it's 200.
That's a typical way to illustrate 200 series blockwork, even though physically it's 190 millimetres wide. It's just a branding thing. At the preliminary stage, it's perfectly okay. So our adjoining wall, our connecting walls, 190 mil thick blockwork, which is RW45. And our floor construction is 200 mil thick concrete slab. And we don't have carpet underlay, but we'll have tiles. The carpet underlay can be good acoustic protection. I don't know if you've ever lived in an apartment where it's solid concrete and tiles, but people walking with high heels and chairs being dragged and things being dropped, you can hear it quite easily. So it can be a bit of a disturbance. It's not too onerous, but it's there. So the carpet can really help with those impact noises. We don't typically have carpet here because it's not ideal for tropical climates. It maintains warmth and we typically walk around with no shoes on and things like that. We want the coolness of the ceramic tiles or porcelain tiles under our feet. So we're not going to have the underlay, but 200 millimetres thick concrete is going to be far greater. It says not less than, but it's going to be far greater than 50. So even without the carpet, it'll be fine. Yeah, so they're 190. That was 45 RW. But what it doesn't say is whether they're core filled, whether the holes have been filled with concrete, and I didn't get the impression from the clause that it had taken that into consideration, because typically the construction doesn't always ask. That's unusual. That's cyclonic conditions, where you have to secure reinforcing in that wall and then connect that reinforcing to the roof so that it doesn't fly away. But that's not typical, and the SCC is more typical. So I expect the RW45 has been given to hollow masonry wall, and if we were to core fill that, that would put it well over and above 50. So it'd be higher than RW50. Yeah. It would be similar in keeping with this concrete slab.
Will render be considered also?
The render does help. There are a couple of construction techniques where render had been included. 13 mil plaster render and things like that. I don't know how much of an RW rating it would add, but it does add some. Yeah. Probably wouldn't put as thick a render as 13 millimetres in solid fine plaster. That's quite significant, but it would definitely make a difference. So I just want to go back now to where our clauses were, because even though we've looked at the different RW ratings for the construction, I haven't actually found the clause that says we have to have it. So I just want to see if I can find that. I didn't write the clause number down when I did this for myself, so Just going to have a little look. Here it is. So F4.5, sound insulation rating of floors. In a floor in a Class 2 building must have an RW plus CTR airborne not less than 50 and an LNW impact not more than 62 if it separates sole occupancy units. So that's about the floor. So F5.4, sound insulation rating of floors. It's all very scientific, isn't it? And then the next one is F5.5, sound insulation rating of walls. A wall in a Class 2 or 3 building must have an RW plus CTR airborne not less than 50 if it separates sole occupancy units. Similarly, an RW50 if it separates a sole occupancy unit from a plant room, lift shaft, stairway, public corridor, which we have, and public lobby or the like, or parts of a different classification. So the external walls of the 2 units will also have to be RW50. But again, it's the same construction material, both the separating of the 2 units and the external walls of the 2 units are all going to be solid core filled concrete blockwork. So they'll be the same RW rating. Number 3, so sound insulated rating of walls will comply with F5.3b, just a couple of, that's if it is needed. If it separates a bathroom, sanitary compartment, laundry or kitchen in one sole occupancy unit from a habitable room other than a kitchen in an adjoining unit. So remember that diagram we looked at yesterday where we were talking about party walls between units where there was a kitchen or a bathroom on the other side of a bedroom? We've got a mirror and flip scenario, so our bedrooms are apart from one another, but if it was not mirror and flip, it was just duplicate, then the living areas and the bedrooms would be opposite one another in the walls. That's not the case for us in this instance. And also any sole occupancy unit from plant room or lift shaft. So just down the end we've got the stairs, and then on the other side we've got the lift shaft. If we just have a quick look and see whether there are any bedrooms adjacent to that lift shaft.
Yes. Oh, no.
Is that a bedroom there?
Yeah, there is.
So this wall here would also need to be acoustically rated. It will be automatically because it's the same construction we've just been talking about, but if it wasn't, if this was the kind of timber framed infill that we were talking about where it's not structural walling, then we would have to make sure that there was acoustic separation here. Now I would argue that it wouldn't be just this bit that overlaps, it would be the whole wall and even perhaps a little further around the corner because, you know, lifts are full of people and talking and chatter and mechanics. Excellent. So a little note here about doors as well. A door may be incorporated in a wall in a Class 2 building that separates the sole occupancy unit from a public corridor, provided the door assembly has an RW rating of not less than 30. So typically an external door will be quite solid. Solid core timber doors are very heavy solid timber, so you most likely are going to achieve that RW30. I don't know if they've got any ratings in the NCC for that. I think it's not included, but it would come with the specifications of the door. So you would use security door. It would be quite solid. You don't typically see transparent glass as an entrance door to a sole occupancy unit because it's not private. But if you had a glass and etched or an opaque glass door, then perhaps it would have to achieve an RW rating of 30 as well. And then an aluminium frame, something like that. So timber, glass, aluminium, steel, as long as it achieved the rating, you could use it. And then it says, in addition to 9C, which is with regards to 9C buildings, there's some information about keeping sole occupancy units separate from kitchens. That's a different class, 9C. I think that's aged care. Where a wall required to have sound insulation has a floor above, the wall must continue to the underside of the floor above or a ceiling that provides the sound insulation required for the wall. Where a wall required to have sound insulation has a roof above, the wall must continue to where the underside of the roof above or a ceiling that provides the same insulation required. So it's making sure that it goes all the way to the ceiling. There's a little bit here about sound insulation for rating of internal services, and we talked a bit about that yesterday as well. So when you've got multi-storey apartments, drainage has to come down from the top and it has to pass through other apartments to get there. So it's all connected together, and you'll often get repetition of floor plans so that the facilities that need that drainage are sitting directly beneath one another so that you can just come straight past with the plumbing and things like that. And remember that image we saw where it was cordoned off and it could be wrapped with insulative materials perhaps behind that. And you can often get access through that same panel into the plumbing if you needed to. There was blockage. So if a duct, soil, waste or water supply pipe, including a duct or pipe that is located in a wall or floor cavity, serves or passes through more than one sole occupancy unit, the duct or pipe must be separated from the rooms of any sole occupancy unit by construction with an RW and plus a CTR airborne of not less than 40 if the adjacent room is habitable, or 25 if it's a kitchen or non-habitable room. And then if a stormwater pipe passes through a sole occupancy unit, it's pretty unusual, but I have lived in an apartment building that had a drain in the roof and like it was an open air garden and you could have, there was taps and things up there, so I suppose that's not quite stormwater, but there was, actually now I think about it, I think there was a floor drain, but it actually went out the building and down, that stormwater, it didn't go into the drainage system. Actually it was really annoying because it would go out of a pipe and then splash 4 stories down. At the tier, there was a lower tier, just the bottom one protruded out, and it was actually really noisy. And I actually had to ask the guy who managed the sprinkler systems for the plants on the roof to change the timing from 4 o'clock in the morning to just a regular time during the day because it kept waking me up. Anyway, so stormwater has, if it passes through sole occupancy, must be separated in accordance with the other same, the 40 and the 25, depending on which type of room it goes through. Whew. I still haven't found the bit that says, did we have it already, where it says you have to have one? Oh yeah, we did. Sorry. Floors, walls, there it is.
Yeah.
Silly me. And that's the specification we just looked at, so we'll go past that. Make a little note on your checklist. Required, RW, minimum RW 50 for the floors and the walls, so the adjoining walls between the 2 units that are connected and the external walls that face onto the corridor. Minimum RW 50 for the walls and the floors. Alright, so we don't have any ancillary provisions, no minor structures, boilers, atriums, alpine areas or bushfire prone areas left. So I think we are done. The pages overleaf, the rest of the checklist, is examples of notes that are included in drafting to show compliance with all the NCC. Then there's a bit of extra information in there about the same sort of stuff that we covered in the class 1 and 10, so if you want to use the rest of the checklist for that, you're welcome to. It's a bit of a funny formatting I've done for this checklist. All right.